everyone. Welcome to this session on architecting data tools. My name is Ramon, and I'm going to be your instructor for today. If you can hear me, I would really love to see in the chat that you can say, yes, I can hear you. Or yeah, give me the thumbs up. I love the emojis in this platform. So that's fantastic. Excellent. All right. So let me share my screen with everyone. Entire screen. There you go. If you could give me a thumbs up, if you can see my screen, that would be fantastic with the emojis, or let me know in the chat. Excellent, excellent, excellent. All right, so this is the link to the repo that we're going to be using for today's session. So I'm going to put it in the chat as well, just to make sure that this is the correct one as well. Yep, that is the correct one. So let me put it in the chat. There is the link for the session. You should be able to see it. You should be able to see it in the chat. And then just to get get us all introduced with one another, it would be great if all of you that are here in the session could introduce yourself, maybe put your name in the, or I guess your name will come up in the bubble, but introduce yourself. My name is Ramon. I'm currently based in London. I work at a company called Selden. We do machine learning operations, and we focus on the last end of the machine learning lifecycle. So if you think about gathering data or building a document with the requirements, gathering data, training a model, evaluating that model, and then putting it into production, explaining the predictions that it makes, and also monitoring the data that comes in and the predictions that go out. That is the bit that we focus on at Selden. And I work there as a developer advocate. So if all of you could put in the chat where you're dialing in from, and what do you do if you're a student, if you're looking for a new role, that'll be great just to get a sense of who is in the audience. And then, so I'm going to be switching. I'm going to try and log into a different screen so that I can see the chat as well next to me, but I only have one right now. But with that said, this is the repo that we are going to be using for today's session. It's called Architecting Data Tools. I would recommend downloading it directly or cloning it directly. The instructions are going to be found down here, where you can clone the repo, CD into it, and activate the environment. You can also click on GitHub code spaces, and this will send you to a repo. You can copy the main branch. You can say what region you're in. I'm in West Europe, and you can say which kind of machine you want to use. The 2 cores should be more than enough for the session. You can use 4. I believe 4. It would be under the paid version. They might charge you. I can't remember exactly what GitHub code spaces charges for the different instances, but I believe it's nothing ridiculous. It's about maybe $1 or so, or maybe even less than that for an hour. And we're going to be together for a little bit less than 2 hours today. So, all right. So that's the link is in the chat for the repo. Make sure you go to it, and then we will get started. Hello, Ole, from Hamburg, Germany. Fantastic. Pleasure to see you here. Hello, Bhupinder, student in Germany. Very, very nice. From Denver. It must be 9 a.m. in Denver, I believe, or so. I might be a little bit mistaken there, but help me there if I'm wrong, Brendan. Kayo, Python engineer. Oh, 6 a.m. Wow, thank you very much for joining us while it is so early over there. Kayo, Python engineer based in Belgium. Fantastic. You're very close to me, so we must be in the same time zone. All right. So while everybody gets set up, it's going to be very interactive, the session. So while I am doing things, you're going to have to be doing them with me, because you're going to have to be changing a lot of things in the background so that you can also have a Python package created by the end of today's session. So there's no particular exercise where I ask you to do something. I'm asking you to do everything with me throughout the workshop. So to follow along with me and change things as required. Also, I'm going to ask you at some point to sign up to PyPI, which is the Python package index or the repository where you install all the things from when you use pip install NumPy, pip install whatever. That's where the packages are coming from. So you're going to have to sign up for it later on towards the later part of the workshop if you want to follow along with everything that we're doing. Another thing that I might recommend, in particular for the notebook that we are going to have in here, which is called 00 Lasso, I would recommend that you make a copy of it so that you can keep the original one intact. It doesn't really matter. You can always come back and download the latest version, or rename it and then do a git pull and then get the one, the original one. So you can always do that. But if you don't want to deal with the hassle for that, then make a copy of it once you clone it and then go straight to here. And that's where we're going to get started at. Now, a word of a quick introductory thing. I might be drawing a few things in this board, which is why I have it here. A quick word: if you have seen the Python packaging ecosystem, or if you have used any of the tools in it, you might have come across some of these ones. So setup tools is one of the OG ones, but it is a tool that I believe was built on top of this utils, and I think this utils is going to be discontinued. Then there's also the with the setup.tools is what you would use setup.py and then setup.config or CFG when you are creating a Python package on top of your main repository. Then we also have Anaconda. Anaconda makes Conda. They do not make Mamba, but Mamba is sort of a spin-out version of Conda. It is much faster to use than Conda, and it has a few niceties of it that allows you to do similar things with Conda, but in a faster, more efficient way. I believe it is created by, I think if it's not Quantstack, Quantsite. I think it is, but I will have to double check on that. But yeah, then you have Mamba. From Mamba, you have two spin-off repos that are, one is Mamba Forge, which I believe is a similar version to Mini Conda, and then Micro Mamba, which is an even smaller version of it. Then you also have Poetry. Poetry creates, I don't know exactly the people that created Poetry, but I do know that it is an independent project. It is, for my understanding, is that it is a very, very good project. And the only reason, or one of the reasons that it doesn't have the widest adoption right now is because it has a slightly different way of specifying dependencies in the PyProject.toml that are not compatible today with what is considered PEP 621. Storing project metadata is supposed to be of a specific, it's supposed to store files in a specific way. And I believe Poetry does not comply fully with it yet. And I think that's one of the main things why it puts people off. So to give you an example, we're going to talk about what this file means. You might not know what it means, but we're going to talk about it in a little bit. This is the way in which you should be specifying dependencies, similar to the way in which you specify dependencies in a requirements.txt file. And with Poetry, you specify them in a different way, similar to how you would specify them, I believe, in packages with JavaScript. Okay, and then we have PDM. PDM, I find it to be one of the nicest tools. We're gonna run through an example using PDM. It is also created by independent package maintainers, and it's quite nice. Flit is another one, is another package. to create Python packages, to package Python modules into packages, and it's quite nice. Hatch is another one. It has, to my understanding, one main creator of the package, but it is very heavily used. I believe Fast API uses Hatch and Hatchling in the background, and here is the repo of Flit. Here's PDM. They have a very nice documentation. And then here is Hatch. And it's divided again into two things. One thing is the backend and one thing is the front end. Now, enough rambling. I hope everybody was able to get set up. We're going to talk through all of these things as we go through them. And just let me ask, who here has created a Python package before? Can you let me know either with a thumbs up or put it in the chat, or who here has contributed to open source projects or closed source projects that require adding code to a Python package? Okay, I'll take that as not that many people. Okay, we have one. We have Kayo. So Kayo, if I make any mistakes throughout the workshop, make sure you point them out and call me out on them. And if anyone else has created packages, let me know. I'd love to know. Okay, so let's go to the first notebook and let's get started with the workshop. So I am in my repo here. And the first notebook is or the only notebook really, is the 00 underscore lasso. So I mentioned in the introduction of workshop, or in the summary of the workshop, or the description of the workshop, that today we're going to be talking about how to take some code from a particular, say, a research paper or a data science project, and how to take that piece of code and make it, or a function that is only written but not expressed in a programming language. How can we take that and then pull it into something that can be usable by other people? And I have a couple of examples to show you with that today. A couple of things on the objective for today. My hope is that by the end of today, you're able to create a Python package, you're able to publish a Python package, you're able to understand the different ways in which you can download a package, and I hope that you are able to understand the different ways of versioning a Python package. You've probably seen, since you have most likely been using Python for a little bit now, maybe quite a lot of years, maybe not that many years, you've probably seen the versions that you attach. We're going to talk about what these numbers mean and how they are used by the community. I am assuming a couple of things from all of you. I am assuming that you have at least 1 year of experience coding, that you know how to use virtual environments. That's very important. And that you do not mind using Jupyter notebooks just because we have them for this session. Here are the setup steps. So if any of you have any issues getting set up, let me know, and I'll do my best to help out. Okay, so now let's go back. So in this notebook, we're going to go over through an overview of what is lasso regression. We're going to go see some papers that use lasso regression. And actually, let me ask, who here has used a lasso regression before? Okay, I saw a little thumbs up. Okay, one person has used a lasso. Okay, a couple of people have used a lasso regression. It's kind of difficult for me to see how many thumbs up I'm getting, but I get the sense that some of you have used it. Who of you have heard of it, even if you haven't used it? Can you give me a thumbs up? Okay, excellent. I saw a few. Okay, perfect. So in this section, what we're going to do is we're going to create a Python package from this kind of statistical model called lasso regression. A lasso regression, or L1 regularization, is a kind of linear model that allows us to penalize high dimensional data sets that go through our statistical model. So we're trying to build a regression, but we don't, if a feature is not very useful for the final prediction, then we're going to penalize that feature and we're going to bring the value all the way down to zero. So lasso regression is usually is very often used with as a method to make the feature set for that you're going to be using to build a model much smaller. So if you think about, let me go here. If you think about all your, oops, all your features, and forgive my writing, when you apply a lasso, so this is your feature space, you're going to end up with a much smaller space of, say, x1, x2 to x all the way to x13 instead of x1 to x100. So that's sort of the idea of lasso regression. We have a massive feature set or a data set, and we believe that from that data set, a lot of columns are not necessary, and we want to get rid of them. So that's the idea behind it. Our data frame is right here, and we're going to try to get rid of this part over here. Okay. So let me go back here. I put the function here, the mathematical function for it, but you don't really have to read it. I don't even think it's necessary, especially if you think about it. If you think about all the algorithms that you have used with the libraries in Python, you use them because you have a high level understanding of what the algorithm is doing and how it's going to help you solve a problem, say build an application or move customers from one place to another based on specific things. So you have a high level understanding of how the algorithm works, but you don't need to build it from scratch every single time. So I put it here for convenience, not for usage or whatnot. And actually, I prefer to give you an analogy of what a lasso regression is. Think of a lasso regression as like a sculpture, chipping away excess material from a block of stone to reveal a refined and elegant statue. So you're building a statue and it's still very rough around the edges. And then so the sculpture, let's call him or her lasso or them, and carefully considers each part of the block, the features, and then decides whether it contributes meaningfully to the last design that the sculpture wants to build. And then whatever doesn't add value, then we're going to chip it away. We're going to take it away. And whatever is good, then we're going to keep it there because we deemed it relevant. So that is a lasso regression. And then instead of telling you how many papers have used a lasso regression, because I mentioned we're going to take theory into data, why don't I show you? So here is an incredible website made by this person here called, I don't know his actual name, but we can find it online actually. So I also have it open here. So by Tom Tumil, he built this website and it's called Archive Explorer. So here I pasted lasso regression and all these papers came up, and all these papers are in one way or another using a lasso regression in it to build a model, to prove something or disprove something. So the function is quite, or the method is quite useful, and is still applied to this day. So some of these ones are from 2022, 2020, and so on. If we keep looking, then we're going to find even more. High dimensional linear regression for dependent data with applications to now casting. It seems that lasso must have been in it. Lassoed boosting and linear prediction in equities markets, and so on. So there's a lot of places that have this kind of method being used. So how do we put that into a package? Well, let's scroll down here, and also you can paste it here and put lasso as opposed to lasso regression, and then it will also give you the exact same result. multi-purpose lasso. Then if you click on it, you're going to see a little description of it. Nowadays, L1 penalized likelihood has absorbed a high amount of consideration due to its simplicity and well-developed theoretical properties. So one of the nice things about it is that it's very straightforward to explain what is happening inside a lasso regression, in contrast to, say, a deep learning model or a neural network, which is much more difficult sometimes to understand what's happening inside, or a lot of the times, potentially. All right, so for the setup, we're going to be using a couple of tools. We're going to be using NumPy, setup tools, build, Twine, PyTest, and at the end, we're going to be using ML Server, which is one of the tools that my company we built, fully open source tool. Check it out if you like. It's a wrapper around Fast API, so you can also go directly to Fast API if you prefer. It offers a lot of niceties, so make sure you check it out if it seems useful to you. So we're going to be using that, all of those tools. And then here we have a couple of ways to get started if you didn't do it in the previous section. So if you did it in the previous section, if you created your environment in the previous section, then you're more than welcome to skip this part. And this part, because you probably already have it activated. And if you look at the requirements.txt here, you have the exact same tools in here as you're doing in Pandas, NumPy, Build, Twine, except for the two testing modules, which you can, if you already install the requirements from the main page, then you're already good to go. Okay, so let's talk about the project structure. Many projects have there's a lot of projects that have different ways of that have been built in different ways. They have different files, configuration files, because they're needed. For example, some configuration files might do a pre-commit. A pre-commit is a way of checking that everything passes before you send all of the code to GitHub and you create or execute or initiate, say, a CI/CD workflow. If you have the same tests locally as you do remotely, then doing a pre-commit will allow you to catch things that might not be visible until your code is running in a CI/CD pipeline. And even though GitHub has a very generous CI/CD credits per month, I believe it is, companies will do many builds and push a lot of code throughout a month. So it is only normal that they will have to spend, that their builds will become much more expensive the more they run them. So this is a nice way to do that. But anyways, that's one of the packages that some places, that some projects might have, a pre-commit hook. What I have here is the most straightforward way of having a package. And as a matter of fact, you can still take things from here and make it even more minimal. So let's walk through what's happening here. So here we have the lasso reg, which is going to be the name of our package. And if you are curious about this, you can see the package. I released it I believe it was last night. The last time I released December 7th. The last version, but this is the package that I created and I uploaded it to PyPI. You can download it with pip install and so on, and you can see the code there. I don't have any documentation for it, but you can see how you could potentially install it and so on. And it's not this one. This needs to be updated in the README, but that's fine because we need to see those kinds of things to make changes to our code base. Okay, so first we have the lasso reg, then we have the dunder init method that tells Python that is a module. Then we have a PyCache. We don't need to worry about the PyCache. That's not going to go anywhere. And then we have the regression.py. The regression.py file contains the code for the lasso regression. Then we have the PyProject.toml. This is probably the most important thing in the whole repository. You can build projects directly from a PyProject.toml. It is an extremely powerful specification language for configuration files. And not only Python uses it now, but also I believe Rust uses it, and a couple of other languages use it as well. Then we have a README, very important for documentation. You want to be able to tell people what your package does, and the README is the face of your project. We should have tests. Not every project has tests. Not all projects or all projects are built in the same way, but the rule of thumb is that you should always have at least one or two tests and try to catch things before they make it into a package that other people are going to use. Once we finish building this piece here, the lasso reg, the pipe project.toml, the README, and the test, we're going to go through a couple of processes that are going to build. First is with this thing here that is called an egg, or that has egg-info, which is going to have different information about your package. And then we're going to have the dist. This is once you build the package, once the package is put into something that can be used by people, we're going to have something that is called a wheel. This is what's going to be sent to PyPI. And we're also going to have a tarball. These two are going, when we say build, we are building binaries, we're bringing the code down to the lowest level we possibly can, and then sending it to PyPI so that it can be easier for other people to download it. So then you're going to see this folder with the build. You see here that I'm using Linux. So the bdist or the build distro is going to be I believe that's what it stands for, build distribution. It's going to be for Linux x86-64. And then the library, it has the code here that it took in the build process. And that's what we're going to get at in a little bit. You should create, you probably have them, but if you don't have them all, then you should create these 3 directories. You're going to create a directory called first package. Inside that first package, you're going to have a lasso reg file. I recommend you to, so here's the first thing that you should do. I recommend you to put to lasso reg. I recommend you to put a 2 or a 3, but you want to change the name for it because that's going to become the name of your package. And because that's going to become the name of your package, and I already have that package taken, lasso reg, you're going to need another name for it. So make sure you take this first line. It's my turn. Okay, there you go. So make sure you take that first line. Copy it. And then paste it down here. And change the, oh no, I was not able to copy that. Can everybody still hear me fine? I'm having a few issues with my keyboard. And let me see. Okay, no, I can type here. Maybe that's only with my VS Code. So let me see. Okay, no, I'm fine. Nope. Let me close it out. Okay, now it's back at normal. Okay, so make sure you do nkdir, create your first package. If you want, you can also change the name of the directory, but there's a couple of lines of code below that are going to take us there, are going to take files there. So you're going to have to change it quite a few times. What I would recommend is this particular one that you see here, first package, lesson reg, that you change it, say for, and actually I would recommend do like your name. I did this for the following package that we're going to create later. So I put Ramon Andres Perez because that's my first name, middle name, last name. So I put rap. And so make sure you do something like that. Put underscore and then the initials of your name so that you can have a file that you can upload later on to PyPI. Okay, so let's get now. Then you're going to need a couple of files. You're going to need the pyproject.toml, and then you're also going to need the readme.file. And even though I have some files in here already with pyproject.toml, I'm actually going to create them again. I'm going to recreate them again for the sake of this example. Okay, so the first thing that we're going to do is we saw that there's a lot of papers using lasso regression, but we're going to need to create a lasso regression. And I've taken the liberty of creating one, a lasso regression from scratch that you can see here, and then we're going to walk through it to build an intuition for it, not necessarily to understand the algorithm itself. What we want to focus the majority of our time is in building the package rather than getting a deep understanding of the algorithm. I trust that you can go over the algorithm at your on your own time and then learn a little bit more about it, or pick a different one that is more related to potentially your use case and then follow along with that. So we're going to start with sklearn, linear model. Actually, I'm going to change this environment for lasso dev. Then we're going to have this data set that has diabetes people or patients with diabetes. Notice that this data set has been anonymized. So what you see here is what you're seeing here is a standardized data set into maybe this is min-max, or maybe this is a standard a standard scalar. I don't know, but we get an intuition of what the variables at least mean. We have age, gender, body mass index, blood pressure, and then we don't know what S1, S2, S3, S4, S5, X6 are, and that's okay. We're going to be tackling a regression problem, which means that we want to predict something that is continuous. So let's see the variable that we're trying to predict. So we're trying to predict this target variable here, which I believe is the level. Let's see. We can look up the diabetes. So the target, we provide information that seems to correlate in regard to scientific literature in the field of research. Feature names might be unclear as the documentation of the original data set is not explicit. Okay, so it doesn't really say what the target is. The path to location returns a tuple. Okay, but it doesn't really matter. It's probably the level of sugar in the blood or something similar. We're trying to predict a continuous variable, and here it is. And we're going to create a model that is going to be a lasso regression, a package that is going to run a lasso regression based on a data set. So let's read in the data set as a NumPy array. So we said return x, and y. And then if you look at x, type of x is now a NumPy array, and the same for y. Something important to notice, y is going to be shaped in 0 column, and then, or sorry, all of the rows that it has and 1 column. So you're going to see, or actually here we have a simple array. But when we do predictions, we're going to see that we're going to need to have the array, instead of an array of 448, we're going to need a 1 row and 10 columns and so on. Okay, so here we are taking, we are splitting the data set by 150. So we're going to take the first 150 rows out of 442. It doesn't really matter. That's arbitrary, and it was part of the documentation example, which for our use case, it serves our purpose. So here we are running the lasso regression, and then here we are getting the coefficients. Notice what I mentioned earlier, that if you have coefficients that are not adding any value to your model, then the lasso regression will penalize them and send them to 0. We can describe the tolerance that we want our model to have. So our model might be very little tolerant right now. If something doesn't add any value, 1 to the e minus to e to the minus 4, then we is going to penalize it. So we could switch that and make it a little bit more tolerant of variables or features that don't add that much to the model. And then here is the intercept. So if we were to get rid of all of the zeros, then we will have the following. We will have y equals intercept, or b, plus x, whatever this number is, plus, and that will be x. I think this is x, x at index 2, or let's put it, because we have the intercept, and then we will have x at 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then x9 with this one, plus some error. And that will be our final regression model after we run lasso, because lasso just told us, yeah, we will not account. We penalize these ones. We won't account for it. And that's fine. So what we're going to be building is a lasso regression here. So if you have done object-oriented programming, you have built an intuition about classes. Classes are like a recipe, and that recipe can contain many things. So for example, if I'm going to make a meal, I'm going to need to hold onto my ingredients, and then I might need to get rid of some, but then I'm going to have to apply different functions into those ingredients to be able to make the final dish. So my class will be make a dish, and then some of the functionality of it will allow me to hold information or products that I'm going to be cooking, and then other functions for it are going to allow me to cook the meal. And at the end, I'm going to do something with that meal. Once I keep the place with it, or sorry, once I use all of the ingredients, then I might end up getting 2 or 3 meals out of the ingredients that I have, or maybe even more than that, or maybe less. So at the start, we always use a init method. This init method, and notice that we have here NumPy, so we're going to be using NumPy in our class. So in this init method, we're saying I'm going to accept 3 parameters, but I'm going to apply default values to them. And then here are the default values. The user can change them as they please, but if they don't do anything, these are going to be my defaults. Self is going to be the object that we use to reference every single variable and every single object that we create. When we use self, we can call that object in a different method. So the init is to initialize the class, to read the class in and assign it to, say, a variable. Then, so here I'm going to run this one, and I'm going to add it to a file. So if you go to first package, actually, let me delete all of this. So notice that we have only 4 things now. So in the lasso reg, you're going to see that I only have import NumPy, and then I have this first piece of the class. That's not going to do anything. I could come here and say lasso regression. If I already had a package there, or if I did this. Come here and say lasso regression, but in reality, this is not going to do anything. It's going to be a method, or I'm going to call it my lasso regression class. And if I do my lasso regression class and I do toll, then it's gonna show me the numbers. One thing that you can do to those numbers is you could potentially update them. So instead of 0.0001, let's do 0.0002. And the next time I print it, notice that we already updated the value. So we're building a recipe. with the class that we're doing. The next one is we're going to do fit. The fit method. And actually, let me ask, does anybody know what the fit method is? Can anybody describe in the chat what the fit method is or what it does? I don't know if you are able to mute yourself. I wish, I hope that is a feature, but yeah, does anybody know or have an idea of what the fit method does? Okay, fit training the model to the training data. Yep, that's correct. So you are taking in some data. And if you think about the coefficients that we just saw up here, these are the things that we're going to use to create our model. So we are fitting those values into a function that we're going to be able to use and call later on. And I'm not sure if that's the proper way of saying that, but this is what fit is doing, is capturing the coefficients, the things that you are going to use to then later on make predictions with the coefficients that you calculate. So you're going to have to do some calculation. Okay, so here we have the fit. So we're going to say self.weight. So those weights are going to be the coefficients. Here I call them weights. And then we're going to say NP zeros. We're going to create an array with only zeros in the shape of the amount of columns that we have. Then we're going to say column stack, and then we're going to stack each one of those on top of it. And then we're going to have the X here, which are going to be our data set. So we're going to pass in the data set. We're going to take in the shape of X. We're going to create the amount of weights that we need for every sample. Then we're going to augment it. And we're going to stack them all up. And we're going to use a function that we're going to define here in a second. We're going to call it cost and gradient. So we're going to iterate over the data set, applying a cost to the coefficients that don't add any value to a prediction. So this cost and gradient function is going to take X augmented, this one right here, and self.weights. So the weights here, the zero ones that we are going to update. So notice here that we are going to return a cost and a gradient. And then for every iteration in a range equal to the maximum number of iterations, so that's going to be this one here, max iter. We're going to go and update the weights by multiplying the alpha and times the gradient. And remember that we determined the alpha here by a 1, but we can change that number into anything we like. Then we're going to apply the function again. We're going to get a new gradient and a new cost. We're going to take the absolute value of the difference between the new cost and the cost. And then if that is less than the tolerance value, we're going to break because it achieved the criterion that we gave it. And if not, we're going to continue. Cost, gradient, and then we're going to reassign it with new cost, new gradient. And again, I know I'm doing a bit of hand waving here because the details of the method are not that important. Here is the cost function. We're going to go through a similar pattern. We're going to calculate, we're going to multiply the features times the weights, and then we're going to take the residuals of that. We're going to calculate the cost. We're going to get the penalty that we're going to apply to a coefficient if it doesn't meet our standard. We're going to sum the cost plus the L1 term. We're going to calculate the gradient, and then we're going to subtract them and make it subtract and equal to the last value. And then we're going to return the total cost and the gradient as well. Again, I'm doing a bit of hand waving here because I want to at least walk through it. If as opposed to just tell you this is the code and that's just what we have. So we are appending this value to the regression.py. So notice now we have the fit here. Then we're going to append the cost and gradient. And then we're going to append the last thing that we need is to append the predict. And the predict is going to take any kind of feature set, any kind of set of values, age, gender, BMI, and so on, and all the other features that we have. and then it's going to pass it through our model, and then it's going to give us, we're going to multiply the augmented one, and then we're going to get the weights. We're going to get the values, the prediction back. We're going to multiply by the weights, we're going to sum it up, and then we're going to get a prediction for a value. So if we put it all together into one big class, this big lasso regression class, then here we have our regression. And then here we have our weights, which are similar to the coefficients. Notice that none of these ones is exactly 0, like the one from scikit-learn, but that's okay. We're building this to test how to build a package, not to make the absolute perfect package in the amount of time that we have together. But what could we do to test whether our package is actually good or is bad? Well, what we could do is, notice that our own implementation is called Lasso 2, and the implementation from scikit-learn is called Lasso without any number whatsoever. So let's compare those two. So here we have predictions for using the scikit-learn implementation. And then here we have predictions using the implementation that we just created. If we look at the numbers of the two, they look quite similar. 172, 161, 112, 128. I mean, it's not super ridiculously off, the two of them. So how can we calculate it? Well, why don't we subtract y predicted by the scikit-learn lasso regression minus the ones that we predicted with our model, take the absolute value from it, and then extract the mean. That way, we're going to get how far off are we on our predictions in the entire data set on average. Notice that. That's actually not that bad. For a model that we haven't fine-tuned, we came up with a couple of functions, and that's what we have. And then we are not that far off from one of the best libraries that exists right now for machine learning. Okay, so another thing that we want to do is, once we have our package, so notice here that now we have our full packaging here. We have a way to initialize our class, a way to fit our data, a way to calculate the gradients, and a way to predict a future value given a new set of features. So we have our function. The next thing we want to do is that we want to test it before we come up with before we come to creating the package, building the package. But how do we do that? How can we start using this lasso regression now that we have it in here? Well, we're going to need to get to the project PyProject.toml. So I'm going to come back to this testing section in a second. And I'm going to skip to building our package. So to build our package, we're going to need something called the PyProject.toml. And I mentioned that this is a specification that was actually created by the co-founder of GitHub, I believe. And it's called Tom's Obvious Minimal Language. It's actually not very obvious, at least it wasn't to me, but that's the name the creator gave to this, and it has become quite popular in the software engineering discipline or industry. So it is a data serialization language designed for configuration files. TOML files use a simple and readable syntax, making them easy for humans to write and understand. Okay, that's more than enough. The minimum kind of configuration that we will need to create a package will be a build system, something that is going to take our code and is going to make it into into binaries, and then we're going to need project information, because once we install it, we're going to want to use that in some shape or form. Okay, so the build system here, I specifies the libraries needed to build our package with all of its dependencies and configurations, and the requires part focuses on specific libraries for the build process, and the build backend specifies the tool that will turn the package into binaries. So the build backend can be any of these tools here. And this one. And setup tools is the most common one, and the one with, I would say, most widely used, if I had to take a guess. So we're going to use that one first, and then later on, we're going to use PDM. Okay, so that's the minimal setup that we need. So how do we put it into perspective? How do we put it into our code? So I know that I have a pipe project.tomo here, but I'm going to override it, and I'm going to have it with this setup here that you see. So I'm going to override that, and now I'm going to do what I'm going to do is I'm going to activate my. Actually, I'm going to create a completely new um, package. Create. I'm going to call it lasso dev 2. And then in that package, the reason why you see python-m pip install-e dot is the m says I'm going to use that module called pip, and then I'm going to use it to install in editable mode the package that is living inside this directory. So I'm going to activate my Mamba activate lasso dev 2. Then what I'm going to do here is that I'm going to do Python. I'm going to move into the directory that I need to be in first, package. Then I'm going to say Python -m pip install -e for executable. You could also do, sorry, for editable. You could also do editable to make it more readable, but majority of people have used -e, and others understand in a straightforward way that is editable mode. So if you make changes to the code, then you won't have to reinstall the application again. So we're going to do dot, and then it's going to gather the dependencies. And notice that it successfully built and install lasso rec. So what do I want you to do in this part here? Before you run this one, make sure you rename this one, whatever you did. So if you put your initials, for example, my initials, I will put RAP for Ramon, Andres, Perez. Then the version is extremely important. And then here we're saying we only have one dependency, and that dependency is NumPy. Whatever NumPy installs on its own, that's NumPy's own doing. So that's the most minimum requirement that we need. So if we open up a Python session and we do from lasso reg dot regression import lasso regression. Notice that now we have our lasso regression installed. And if we do help lasso regression, and it will tell us about the method, but it won't tell us anymore because we haven't really put any documentation, any doc strings in it. But we finally have successfully installed locally our package. Now, what do we do with it, or what do we need to do now? Let me exit here, and then let's come back here. So that's the minimal setup that you must have to create a package locally. But to be able to add it to places like PyPI, you're going to need a little bit more information, and you're also going to need your project. You're also going to need to have your project hosted somewhere like GitHub, GitLab, and Bitbucket. I believe is the other one. So here we have a couple more things in the requires. And we have one more, and this one's called setup tools underscore scm .tomo. What this one does here is that it helps us manage the version that we have here dynamically instead of manually. One thing that you should note is that we're going to have to add the version here, but not only here. We're also going to have to add the version in our lasso reg init method. So this is a requirement. So if you do it manually, you're always going to have to change the version in 3 places. Git tags, because you want to tell your users what version they're going to be using when they go to read the repo on the latest updates of your package, the Tomo version, and then the init version. But using the setup tools underscore SCM Tomo, then you can avoid that and you can change this to dynamic. Then you can come here and say version. But that requires that you are very meticulous with your Git tags and a bunch of other stuff. And while that is fine for our purposes here, we can go with the normal way of doing it, where we add it to all the other places. Here we have a README file. We're going to point to a README file. Our projects should have a README file. And then we're going to say we're using MIT license. You could use any license that you want. Notice this. You can also point the license. Instead of giving it this dictionary, what you could do is that you could point it to a license file inside your directory, inside here in first package. So we could do that, but that's okay. We're not going to do that right now. We're going to just say, this is the license that our project uses, and that's okay for us. The other thing that you should notice is that we're saying requires Python 3.11, either 3.11 or greater than that. That's okay. If you want to relax that, you could do 0, or you could do even Python 3.9, and that should be fine. Notice also that I have my name here. So I want you to change this part. So you're going to change the name. You're going to add your name. So you're going to change the name of the package. You're going to add your name. And then you're going to add your email if you want to. You don't have to. You can leave it empty if you like. Then also, I want you to add a description. Change this description here for the sake of the example of the exercise. Change that description. Maybe add an Apache 2 license or a GNU license. And then here are the dependencies. The dependencies can also be added in different ways. So just to give you an example, if I was to add NumPy as 1.201 as such with a little, what do you call that? A little, not tilde, but I forgot what the actual name of that was. It's saying use at least this, use any package of NumPy that has at least the same features as this version. If it doesn't have them, then don't use them. But it restricts NumPy from going to version 2. So if they were ever to change this major version here to 2, then it would never go there. It would only stay on the highest one of 1 point whatever the next one is. Okay, and then one of the things that you can give to your package is some keywords so that it is easier for other people to find your package. You can also give it different other things, and I forgot the exact name of the other stuff that you can give it, but you can give it keywords and a couple other things to make it easier for other people to search for it. And lastly, the project URL. So when you go to PyPI, you're going to notice that it's going to have a source, project link. So that source, oops, I must have misspelled it because it did not take us to the page that it was supposed to take us. So HTTPS Ramon PZG architecting tools first package. Let's see. First package. Okay, so that's probably because here it has tree, main, and so on. Let me see if it works without it. Nope, it doesn't. So I'm going to have to change this one in here to the correct one. Tree, main, first package. And now in PyPI, whenever I upload it, then it's going to have the appropriate source link to my GitHub repository. So I'm going to add this next one. So notice that PyProject.tomo only has a build system and a project. Now we're going to expand that. Let me see if there are any questions. No questions so far. Let's see. Okay, so now, before we move on, let me do a quick word on the version system. So when you see 0, 1, 0 dot, a number dot, another number, the first part is a major version. So I think I have it here. The first part is a major version. Then the second part is a minor version. The third part is a patch. The first part means the whole library or the whole package has been revamped. It has new features, it has new code, it might have breaking changes, is a newer version in all sense of the word. And then the minor version might be is often used for new features that don't break, that are backwards compatible, and they don't break the code that you already have. So, for example, if you are in Python 3.11, you might have noticed that Python 3.12 came out with a lot of new features. All of those new features in Python 3.12 will not break. Sorry, even though all of the new features in Python 3.12 do not break, are not available in 3.11, those new features don't break features on 3.11. So that's the minor version, something that you use, a way of signaling to users that there's new stuff in the package. And then the last one is kind of like bug fixes, documentation improvements, new tutorials, and things of that nature. So if you refactor code to make it more efficient, and the parameters that it takes are the same, the functionality of the function is the same, everything is exactly the same, but it's just more performant now, then that could be considered a patch. Some people might consider it a new feature, but there's no real new feature there if the function is doing the same. So you are safe to treat it as a patch, and then increment your version by if it's 3.2.1, you can increment it to 3.2.2, and so on. Okay. So how do we publish our package? The last thing that we want to do is we want to add a README file to our package. We want to add something that's nice, something that other people can go ahead and read and get a sense of what the library is doing. So I'm going to override this one, and then I'm going to have a README file here. And then if I click preview, then we can see it here on the left-hand side. So pip install lasso reg. You could actually do that right now. And then from lasso reg, that regression, import lasso regression, we can add it right here, fit a model, make predictions, and so on. And then there's no example here, but I added that because you would want to have some sort of example to run. You want to have some tests as well. This is exactly what it does to my directory. You will go PyTest tests, and then you will run all of the tests that you have. So we will see that in a little bit. So now we have the README file. And what we want to do next is we want to build our tool finally. So I'm going to clear my terminal. And then I'm going to first pip install build and twine. So now that I have them, I'm going to clear here, and then I'm going to do Python-m. Notice that I am inside the first package, my project directory. So I'm going to do Python-m build. That is going to create an isolated environment. It's going to capture all of the tools that it needs and all of the packages that it's going to need. It's going to download NumPy and everything that is in it. And then it's going to create two things. So notice here that it says successfully built lasso regression 01.0.targz, and then a Python wheel. So these are the binaries that we need to be able to upload it to PyPI. And if I want to change the version because I did some new things to it, we can also do that. So if I come here to that init and I say 1.1.1 and I save this, and then I come back here to my project.toml and I also reflect the change here for 1.1.1 and I save this file, I can come back here and I can do build again. And notice that now it's saying lasso reg 0.1.1. And notice that now we just changed that. Lasso reg 0.1.1, and then the same is here because we changed the version of it. Okay, so the next step, oh, and actually let's talk about these two files. So the wheel, the purpose of the wheel is a format. The wheel is a format. The wheel format is a binary distribution format that aims to be more efficient for installing Python packages compared to the traditional source distributions like tar.gz. And then and then the advantages of that is that it's faster, it simplifies package management, and then is platform specific. So they can be platform specific, the wheels. And then the tar, this source tar is a compressed archive of the project's source code and related files. So it contains everything you need to build and install the project. So the nice thing about this one is portability. So you can use the tar.gz to install it anywhere, but you can use the wheel to install distribution specific files. So in my case, I'm in Linux, so that's my distribution. Okay, so the last thing that we want to do is that, or one of the next things that we want to do is that we want to understand the different ways in which we can install this package. So to give you an example, if we were to come here and say, let's clear this, and then let's do git status, and then I added quite a few things here. So I won't add the PyCache, but I will add the regression. I could add the regression. I could add this lasso and so on. But because my package is already in GitHub in here, I could also install it from there by copying this URL and come here. I'm going to leave this. I'm going to leave this environment. Let's say Mamba deactivate, and then I'm going to activate any other environment that I might have available there. I'm going to activate this one. I'm going to clear this, and then I'm going to do pip install. And then I'm going to do here git plus. I'm going to paste that first package there, and then I'm going to do this here. I wonder if this is because I can take this off for this one. Let's see. No. So if I come to this one, okay, so I think because I have two packages already in my GitHub, I think there's a way to do a specific. Usually, you will have a Python package and you will have its own dedicated repo. You might have different ones and so on. But I have two right now in this one, and instead of does not appear to be a Python project. No, it isn't, and it doesn't have a set of tools. No, it doesn't. This one is the one that has a set of tools. So that's okay. I won't spend too much time on it. I wanted to give you the options or show you the options that you can use. You can have your and you can check out. I put here the place where I had a look at these instructions. They are fantastic. So this is a tutorial that I found just this morning, and so you can have your user and your project. If your PyProject.toml is inside your main repository. If you want a specific version of that repo, you can say, I want this version. And then if you have put tags in each one of the versions, then it's going to know which one to use. Then you can also do it via branches. You can also do it via hashes, and you can do it via your package. And so, oh, sorry, and you can also add it as a dependency. Remember that earlier we added the dependencies to pyproject.toml, and we put numpy here and import live metadata. Well, what you could do is you could also put a package directly from a GitHub repo as well as a dependency. So you can get quite creative with the ways in which you can install files from using pip from different places. So your file does not need to be in PyPI, but there's a caveat. Files usually download way faster from PyPI than they do from Git. From Git, pip is going to clone the entire repo. So if it is quite a large repository, you might not want anything other than the binaries for or the wheel for your specific distribution. You might just that might be the only thing that you want. But now you're getting the entire repo, and that's going to take a little bit longer for you to be able to do it. Okay, so to be able to publish our site to PyPI, we need to go to PyPI and we need to create a account. I have already created my account, but as you can notice here, it's a straightforward process. Put your details and your credentials. It's going to ask you to verify your email address. And then once you verify your email address, here I put email address, my company email address. This is your primary address. Then one of the things that they suggest is that you do two-factor authentication. Two-factor authentication, I believe, is going to be a mandatory requirement at some point, if it isn't already. And once you have that set up, I have it with an application on my phone called Auth. And then you're going to have to create an API token. That API token is going to be a very long piece of string. And then that string, you're going to give it a name, or that API token, you're going to give it a name. I put here architect tools, like the name, similar to the name of the workshop. I put the scope is all projects. If you have more than one project or multiple projects, you can assign a token per project. And that's actually a better way to do it than to assign to one token access to everything you own. So that's the best way of doing it. I last created this one about 6 hours ago. And then here you can add another API token if you have a different project and so on. Once you have it, once you have that API token, you're going to create something. I know this is quite involved, but you're going to have to create a config file for PyPI inside your home directory. So I come here and I do ls there you can see, and actually it's not ls really. There you can see my PyPI RC, my PyPI RC file. And if I vim in it, it's okay. I'm going to destroy the token after the session or generate a new one. Then you can see that I have my username, the token, and then I have my password here. That's what you're going to need. And then now that we have that, we can use Twine, the other tool that we downloaded or that we installed with pip earlier. So if we use, let me go back to our previous Lasso Dev2. So I'm going to do Twine. The first thing that you want to do is that you want to check if your package is okay, if it is working, or if it was built as expected. So we're going to do Twine check list. We're going to check both packages. Notice that if we look here in the dist, we have Lasso, Reg, we have several wheels. we have one for 0.1.0 and another one for 0.1.1, and the same for the tarbles. So here we're going to check that all of them were created successfully. And notice that the first version successfully, the second version successfully, first version successfully, second version successfully. They passed. So now what we can do to upload it to PyPI, notice that if we come here, the last version was 0.1.0. I'm going to do twine upload list and all of the files. Notice that we have a star for uploading more than one file, but we can be very specific and only import the wheel, or we can be very specific and only upload a specific file or a specific version. So that's also something that you can do. Okay, so once we do this, then retry, verbose option, distribution, legacy, lasso array. Oh, the file already exists. rm-rf is okay. So I deleted those two, and then I'm going to do twine upload this again. And now I'm updating. So you can only have one version at a time, I believe it is, in PyPI, and the same in your repo. So if you're working with a new version of the file in a different branch, then that's when installing from GitHub becomes quite useful. When you are working with different people, everybody's on their own branch, and they tell you, "Hey, I want you to try this thing that I've just been creating. Can you please have a look at it?" Then you will install it with GitHub. So notice that now uploading distributions to PyPI, uploading lasso reg 0.1.1, Py3, none, any wheel, uploading lasso reg. So we uploaded the tarball and the wheel, and then it tells you you can view this in here. So if we go to PyPI, oops. Notice that now we have the newest version of it. And the way we can install it is as like this, because we haven't made it the master version. I believe this is because I haven't made I have not made the latest changes to GitHub, so it is not matched with. Oh, actually, yeah, it is. We can do this is the last one, so we can go specifically to a particular version. Let me see if I can also do 0.1.0. And you can also go to another version. So how cool is that? That you can keep different versions inside of PyPI, and then it tells you, it gives you a warning here saying there's a newer version, 0.1.1, as opposed to using this one. So if you erase the specification and go straight to the latest one, then by installing pip install lasso reg, then you're gonna get the latest one. So I'm gonna copy this. I'm gonna come back here. And what I'm going to do is I'm going to install that one here in a second. Okay, so we're at the last piece of the puzzle, serving our machine learning model. So what we're going to do is we're going to download the library, train a model, save a pickle file, serve it, make predictions. So here, if you notice, I'm going to do pip freeze. Notice that we have this file here from our editable mode, and we kind of want to get rid of this. But even if we get rid of it, it doesn't mean that we have. So notice we don't have anything called lasso reg. So right now there's no lasso reg. So if I do pip install lasso reg, this is already satisfied. So let me actually oh, that's fine. I can leave it there. So now we pull our library, and just to show you that it is being installed from somewhere else. So deactivate, and then I'm in my base environment, as you can see up there. And if I do pip freeze, I do not have a lasso reg. So I'm going to do, in my base environment, I'm going to do pip install lasso reg. Oh, notice how interesting. Because if I do which Python or sorry, Python dash version, this is quite interesting. I have 3.10.10 here, but in our PyProject.toml, we said that we would only accept 3.11. This is great. So if we do mamba create -n, we do lasso dev 3, which will be an empty environment. It has nothing other than Python 3.11. Then we can install our lasso reg file. So I'm going to come back here, and then what we're going to do, we're going to install it, then we're going to read it in. Okay, so let's do this. So now we have lasso dev 3, and I'm going to do pip install lasso reg. There you go. It's being downloaded from successfully imported lasso reg 0.1.1 from PyPI. So that's great. And it also installed NumPy. And so we have very minimal dependencies for our file. So if we do Python, we do, oh, this one is using 3.10. We do Python here. Now we have Python 3.11. And if we do from lasso reg, that regression, import lasso regression, then it works. And if we do, we're going to copy exactly, well, actually, I can do it here as well. Pip install lasso reg. And then from lasso reg, that regression, import lasso regression. Then we're going to create a third one to make sure this works. We're going to import pickle. Remember that we still have our X and Y value from earlier. So here's our X value. And here's our Y value. All the things that we need to predict, the numbers that we need to predict. So if we want to import pickle, we can say with open dash models dash pickle model.pickle, save it as a WNV. So we will have to create a mkdir models directory in our project. So up here at the project level, at the big project level, we're going to create models. It's my models directory. And we can save our model in there. We can load it back in. Notice that we have the lasso reg regression lasso reg function already, or the model already loaded. Notice that we need to have I mentioned earlier that we need to have the array of features as one row and then 10 columns, as opposed to a single array, a one-dimensional array. It has to be a two-dimensional array. And then here we can do predict, and then we got a 161. Okay, so the last piece of the puzzle is, what if we want to make this function, this package that we created, what if we want to make it useful? What if we want to create a service with it that we can send requests to? And then, say, for example, we're working at a hospital, and um, at the hospital, our data scientists, they're making tools to be able to tell diabetic people where to predict where their glucose level is going to be at in the future. So the doctors ask them, hey, can you create a service? And then to the front end, can they create a UI where we will input patients' information, and then we will get back a prediction of their glucose level, maybe not today, but maybe next week, maybe in a week, in 2 weeks, or in 2 months, and so on. So I mentioned that at my company, we built this open source tool. There's a wrapper around Fast API, and it has a lot of useful functionalities. It's called ML Server, and I really like it. I think you might find it quite useful. So here's ML Server. And what it does is that it allows you to serve any kind of model that you want, and multiple models of it, do batching for predictions, and with a straightforward user experience. So let's go and check it out. So I have here some codecs, which are ways of encoding and decoding a request. If you have ever worked with requests, you know that you're supposed to do you're supposed to have your request in a specific shape and form to be able to talk to an API. These APIs are compliant with the Open Inference Protocol, which is for machine learning purposes alone. And so here we have a decode args. We have a model URI, which we're not really going to use, so that's okay. We have the main class, the ML model, and then we have our regression file, lasso reg that regression, lasso reg. So then here we have from sklearn, we're importing the data sets. So we're gonna do the whole thing in here. And then we have NumPy. We're not even going to use Pico because we're going to train it right there in there. So there's a couple of ways that you can do this. So we can load in here the model that we created. We can usually, you don't want to retrain it, but I put it here as an example, for example's sake. So here we have the data set, load the diabetes data set, train the model, and then assign the model to this self.model class, and then return true. Then in the next one, in the next piece, we're going to take in an array, a NumPy array, and then we're going to put in those features inside the predict function, and then we're going to return some predictions. So I'm going to assign this model. Notice here that I have a directory called server. I could delete the whole thing. Let me see. I'm going to do that, just that. I'm going to delete the whole thing. There you go. And then now we have an empty directory called server. I'm going to create this file called my lasso. So that's the specification of my model. And then there it is. Then I'm going to create a settings.model. So I have to tell my server what is the name of this model and what is the implementation method. The name of the file is my lasso, as you can see here, and the name of the class is lasso CLS, as you can see up here. And then I'm going to have some server-side settings. Whenever you have a server, you're going to have people communicating with it in different ways. So you can have an HTTP port. We provide a gRPC port as well. And then we also provide a metrics port that you can connect to and then create visualizations from the requests and the things that are happening with your model. So I'm going to add these two elements in here. Notice that now I have these two. Now that we have the files, we can say ML server start. Then we can go straight to the name of the server, the directory. Let's move back one. then ML server start server. And then notice what happened. It's if you've ever used Fast API, this is probably going to feel a little bit similar. So it's telling you the metric server is running on this port. The prediction, the HTTP server is running on 7090, and then the gRPC is running on 9090. It loaded successfully our model, and then now we can send predictions to it to make sure that it works. So we're going to import this NumPy codec, which takes in a NumPy array and puts it into the shape and form in which requests for the Open Inference Protocol work. So we're going to import requests and that codec. We're going to add the endpoint, which you can see here is localhost 7090. So localhost 7090, we're using the V2 inference protocol or Open Inference Protocol. We're using one of our models. The name of the model is lasso_service. And then we're running inference on that model. So now we're going to select a sample. So let me actually split this ones. It's going to be the sample that we're going to send to our service. And this is how we structure the input request that we're going to send to that service, to our API or to our microservice. And now we're going to send the request with request.post to the endpoint using that inference request. And then we're going to get two things: a response of 200. Here it says okay 200, and then here we have the prediction 161.21, and that's the data. So that's pretty neat. Now we just went from creating a package that implements a statistical method to deploying serving that method. We haven't deployed it to the cloud, but it is technically living inside our computer. And because it's living inside our computer, then that means that we could potentially have people access it, but we don't want that. We want to serve it somewhere else, of course. Let me see if I have any questions. I haven't checked the chat in a little bit. Okay, so good question. Next, does that mean that backward compatibility issues occur only when major versions changes? Yes, that's usually correct. People don't, or package maintainers and application creators usually don't try to, when they add a new feature, they usually try to add features that will not disturb the current workflow of users. You never want to betray your users, because otherwise they will go to a different tool. And then that can mean a lot of things in open source. For example, if you count on people contributing to your open source projects, then you definitely don't want to betray their trust. People will, if you introduce breaking changes into minor versions, you will slowly or very rapidly lose the trust of your users. Good question. Okay, so now that we created this one, now let's go and see how can we make a package. So this is a very manual way of doing it, because we have what's it called? We're using setup.tools, and we're doing things quite manually. But there are better ways of doing or creating packages today, and I'm gonna show it to you in about a couple of lines of code. Okay, so okay, so the first thing that we're going to do is that we're going to get out of here, out of the 00 lasso, and then we're going to also get out of this one, and we're going to get out of this one, and we're not going to worry about this package anymore. Now, imagine that we wanted to create a decision tree, and that decision tree classifier is going to help us classify things, and it's going to be the stepping stone into getting into more complex linear models or more complex tree-based models like random forest or gradient boosted trees. We have to start, we want to start a little bit smaller when we are proving, when we're creating a proof of concept. So what we want to do is, I have here a second package that has already been built and everything. But what I want to do is that I want to create one from scratch. And also notice that I forgot to say that I forgot to run the test for the first part. So if we come back here, actually, um, and have a look at the test, we're using two libraries, Hypothesis, and we're using PyTest to create different kinds of combinations of tests. So I'm going to run these ones quickly and then make sure that things work as intended. So pip install PyTest. I'm going to switch to first package, tests. I'm going to do PyTest. Notice that I have an error here. Module packages must have valid names. So if we come here to the first package and we go to test, we go to test lasso. Okay, let's see if it was something with my environment. Yeah, I believe it was something with my environment that I was missing. So notice, because I ran the test before starting the workshop just to make sure they worked. So they do pass, but they say there's two warnings here. And then if I walk you through them, we're generating random data with hypothesis, with the draw strategy. And then we're creating integers of minimum values, maximum values. We're creating lists and floats and so on. And it's going to generate random data at test time. Then we're going to create test lasso regression. We're going to say that are the weights being captured? So essentially, are there weights in here? So if I change this one and I say, actually, we didn't even fit the model. There's no weights there. There's going to be a weights parameter because we instantiated the lasso regression, but there's not going to be any weights. So if I save this and I run my test again, this should fail. There you go. We have one failure and it says self.weights, that alpha, this did not get used. So that means that our tests are working fine. So if I come back, and you should always try to break your test. If I come back here and then I run it again, and that should be that is working fine now. But it still gave us 3 warnings. So we still need to do some stuff to make them as good as possible. But we have some tests that will work. We're saying, are we creating predictions? Yes, no. Are the weights available? Yes, no. Test lasso regression convert. Sorry, are the weights available during the fit process? Yes or no. And then this one is, is the model converging? Is it reaching a valley where the predictions are as best as they can get in those amount of iterations? And so on. Okay, so now that we have that, let's go to the next part. So I'm going to get out of here and get out of this one as well. And then notice that I have a bunch of stuff in this second one. What I want to do is I want to create, actually, I'm going to leave it as such, and then I'm going to create a completely new one. And I'm going to say clear Mamba deactivate. Mamba activate. Oh, actually, leave it like that. So the first thing that you want to do to be able to use PDM is that you want to have it isolated in your environment because it's going to be a package manager. As you notice up here, I have a base environment. That base environment is signaling me that I have Conda installed, and there's a base package that is always going to have a Python distribution in it. That Python distribution, my base Python distribution is 3.10.10. I can change that if I want to, but right now it's serving a purpose, having that base environment in it. So what I want to do is I want to have something similar. And how can I have something similar for PDM? Well, the way to do it is with something called pipex. If you have never heard of pipex, pipex is a way of pipex is a way of installing command line tools isolated in your computer. So if I am going to run Conda and I install Conda with pipex, then Conda is going to be its own isolated thing, and so on and so on. So with pipex, you can install PDM. But so you can do, once you install pipex, you can do, and let's come back here, installation process so that you can see what it is. I have a Linux computer, so I follow, where is my personal one? Okay, I believe I used a package manager when I installed it. I think I used sudo apt get install pipex. So I have pipex inside my entire computer. And if I do pipex dash version, as you can see that I have 1.2.1. So once you have pipex, what you want to do is pipex install PDM. It's gonna tell me that I already have it. PPM already seems to be installed, not modifying existing installation. It is in this location. So that's fine. I can force the installation, but I already have it. So what I want to do now is I want to create I already have a directory called third package, and that's where I'm gonna go. I'm gonna go back to my architecting tools, and then I'm gonna go into third package. In that third package, I'm gonna say PDM. That's gonna give me all of the tools that I can use with PDM. And now what I want to do is I want to create a new package. So how would I do that? Well, we can use the init method. Initialize a PyProject.toml for PDM. So we're going to do PDM init. Now it's going to ask us a bunch of questions. What kind of Python distribution do you want to use? Do you want to use your base Python in your computer? Do you want to use the one in Mamba Forge, Python 3.10? Do you want to use regular Python 3 from Mamba Forge? Do you want to use the pipex Python version? Do you want to use the 3.9 version? And so on. So I'm going to say, give me the one with Mamba Forge, where I don't have to type 3.10 every time that I'm going to run a Python file. So I'm going to put 0. And then it says, would you like to create a virtual environment in the home for this directory? And I'm going to say yes as well. Then it's going to ask me, is the project a library that is installable? If yes, we will need to ask a few more questions to include the project name and build the backend. The default is no, but of course, we want to have a library that is going to be installable in our computers, especially if we want to become more efficient at different things. And we have been making packages so that our developer experience is nicer and smoother. So I'm going to say yes. And then the project name, is it going to be third package? No, I'm going to call it decision trees. And then what's the version of this package? What do you want it to be? I'm going to say 0.11. And I'm going to add a description. This package is an implementation of decision trees in Python. Then I'm going to say, it's going to ask me, what kind of backend do I want to use? I want to use PDM. Notice that you can use setup tools, which is the same one that we were using before. You can use Flick Core, and you can use Hatchling, and so on. But it doesn't give you the poetry one because it doesn't adhere to the PEP 621 that specifies how a PyProject.toml should treat dependency numbering or dependencies versions. I want to say 0. I'm going to give it a license. MIT is fine. The author name, notice that it picked up my name from my Git configuration, so Ramon Perez. It picked up my email as well, my personal email. And then it says it requires greater than Python 3.10. And then we're going to say, yes, that's fine. Anything above that is okay. And now we created a successful project. So now let's evaluate what we have in this project. So we have a virtual environment here that we can activate via the bin directory. We have a source directory. And notice that before, we had at the top level of our directory, we had the package name, and then we had the files inside of it. Now we have a source directory, and then we have a name for the package, inside that source directory. So those are two completely different things. And why is that? Well, when you have a source directory, you can add multiple files inside the same directory without confusing getting confused or getting trapped into adding a file inside the root directory and then having that file or that new package conflict with other packages. So I can have different methods here: decision trees, random forest, logistic regression, and so on. And not fear that they're going to clash with one another because I can separate them there. Okay, so now that we have that, we also have it also created for us a PyProject.toml, a git ignore. And then notice that this PyProject.toml, it has my name, my email, the description, the version, the name of the package, the README file that it created for us, the MIT, and then the backend, the license, the backend, and so on. We haven't put any dependencies, but we're going to add NumPy. We're going to save that. And then notice that the README has nothing. The test has nothing, but it has some Python files in it. So in the decision trees, what we're going to do is that we're going to add a file. And that file, or actually, instead of us adding the NumPy one here, we can actually leave it as such. And we can use PDM's version of adding files. So we can do PDM add NumPy. Notice that it went in and it said, look, successfully changes are written into PyProject.toml, install NumPy 1.26.2 successfully, install decision trees 1.1.1 successfully. So now we have an environment here called VM, and then a PyProject.toml with NumPy fixed, the version of NumPy fixed to being greater than or equal to 1.26.2. So that's great. That's what we needed. Now, what we're going to do is we're going to create our decision tree file, and we're going to call it classification.py. And then in that classification.py, I'm going to put some code that I have written, and then I'm also going to add it to the repo in a little bit. So in the source, I'm going to add that code here for simplicity and or for the sake of time, because I know we're running out of time. I have about 4 minutes left. I think I can make it in that time. But so we have a decision tree. We have the init method where we're taking the max depth of a tree. We're passing this to in here. The tree is going to be none. Then we're fitting a model using build tree. Build tree is this function here, which is saying, give me the unique classes or the unique feature names inside, or sorry, the unique classes inside the target variable. And then if the unique classes is equal to 1, then return unique classes 0. And then if the max depth is not none and the depth is equal to the max depth, then the majority class, we're going to take the argmax. We're going to get the index, so the maximum numbers. So we're going to go through the whole algorithm of making a decision tree. And then we're going to find the best split. We're going to calculate the Gini index, which is the metric used for decision trees. We're going to have a predict function. And then we're going to have a predict tree, predict the class, predict the tree. So that's our method. And now that we have our method, one of the things that we can do is that we can test the scikit-learn implementation. So we can do Mamba activate, Mamba create tree dev. See if I have any questions. How would that look with Docker Compose? That's a great question. You could, and are you referring to the server for the model, or are you referring to building the Python packages with Docker? You can definitely do that and have them in an image and have somebody that wants to use your package use it via the image. But that might be a little bit overblown depending on the, I feel like that might be a bit of an overkill depending on the use case that you have. But it's definitely doable to run packages with Docker. Okay, so I see here, where can I serve my trained models online? I have tried out on Hugging Face using Gradio interface. Do you have any other suggestions? I do. I'm going to come back to that question in a second as soon as I finish this one. Bonita, if installer wants to run the unit test, okay, maybe a question of taste to have tests runnable out of the box. Oh, of course, we definitely want to have the test running all the time. I put them here as a second thing to make sure we walk through the process of creating the package. At the end of the day, tests are going to be very dependent on the user, on the person creating them, rather than depending on the use case itself. But like I might write tests different than you, and you might write tests different than your colleague, and then we all converge when we review each other's code. So that's why I left it for like an afterthought, because especially machine learning, you can go in many different ways with the testing. Pipex is managing seamlessly Python environments, or is it doing one more? No. So Clement, that's a great question. Pipex is creating an environment for every single Python tool. My understanding is that it's creating an environment for every command line tool. So it's specifically for command line tools written in Python. And it creates an isolated environment in your computer somewhere for that tool. So you can always have it. It doesn't matter what, you don't have to worry about having environments activated or not when you're trying to use a tool. And then does Pipex also download the dependencies for a specific library as well? Yes. So if you install a specific command line tool and that has some dependencies, so it's going to do the same normal installation as pip. So those are all great questions. And I'm going to come back to 2 questions here in just a second. I have about 3 more minutes. I know we're just at time. So bear with me. And I understand if some of you have to head out. That's totally fine. So I am going to activate this environment. And then let's see. We are going to do pip install scikit-learn in this one. And then what we're going to do is that we are going to test a implementation, or we're going to see how can we, if we already have this here, if we already have this package, how can we get it up and running? So what we're going to do is we're going to do PDM. Now that we have our tool, let me actually get out of this. In the interest of time, I'm going to get out of this one, and I'm going to do PDM build to create the package that we're in. So we're in the third package. So I'm going to do PDM build. Notice what it did. What it did was it created a wheel. So here we have decision trees 0, 0.1.1, pi 3, none, any wheel, and so on. And then here we're going to do now PDM publish dash no build. Now, notice that the user Ramon PZG isn't allowed to upload project decision trees because decision trees is already taken. It's a package that is already taken. So I'm glad I hit this error. I did it when I was creating this session. And so what we do here is that we need to come here and we need to say, okay, decision trees is already taken. But I mentioned earlier that I had to create decision trees wrap. So my initials. So what we could do instead, if we want to create a new package, we could do decision tree, and I'm going to do wrap. So I'm gonna take one S out of it, and then I'm going to save that. And then I'm going to rerun my publish. So I actually probably need to build it again. PDM build. So notice what we just did. So he gave me the URL, but notice that within 3 lines, PDM init, PDM add dependencies, create your code, PDM build, or about 4 or 5 lines, PDM build and PDM publish. Now we can go straight to PyPI. Notice that this one is decision tree without the S at the end. And now we can install this from PyPI. So I'm going to take this one and I'm going to come back to my terminal. I'm going to do Mamba activate the second one that I just created, tree underscore dev, and I'm going to add the pip install decision tree wrap. I successfully installed decision tree wrap, but remember, so this is quite important. Remember that the name of the package at the top is decision trees. So if I want to use, I'm going to do Python. Actually, let me do pip install IPython. Then I'm going to do from decision Okay, there it is. I did not have it installed in that one. So decision tree from decision tree dot classification import decision tree classifier. So now I have my decision tree classifier, and now I kind of want to test this. So I want to see how can I test it with scikit-learn. So what I'm going to do is I'm going to do from scikit from sklearn dot datasets. I'm going to import make classification, and then I'm going to do x y equals make classification. I'm going to make 1,000 with 10 variables, and then I'm going to do dt classifier decision tree. I'm going to instantiate my decision tree. I'm going to do dt classifier that fit those two variables. Then we're going to do dt underscore classifier that predict. I'm going to do my x. Notice that I successfully created a decision tree that makes predictions. I installed it from PyPI, and then I used it in my terminal. So this is really all I have time for, but I hope you found it useful. A couple of things that I wish I would have been able to cover in this one were adding some tests and then some CI/CD. I think the most important thing that puts people, I feel like I find that put me off for ages from making a package or learning how to create a package was that there was a lot of tools, and it feels a little bit intimidating to go through all of them and try to figure out how to put together a package. Sometimes you go to GitHub and you find a million lines of code for a project that you really, really like, and you wonder or you ask yourself, like, how am I going to make something like that? So I feel like I personally was put off for quite a while because I found that there was a lot of options to do something, and then I just kept on putting it off. And I hope this too, the very base one, the most straightforward one to make one, and then another one that is much, I find them much nicer, PDM. You can try other tools as well. I hope that you find them useful, and that you can also and actually I want to do one last thing before we part ways. I want to show you something really cool that you can do today with language models. So if I go to, I like the context windows of Claude, and then we've been talking about research papers that we can translate into functions. So if we do let's go back to archive, sorry, applicable lasso. So I'm going to hit this one, and I'm going to click view, and then I'm going to say download this one, and then I'm going to take this URL, or actually I might even download this file. Yeah, let me download this file, applicable lasso. And then I'm going to go to Claude, and then I'm going to open this archive file that I just downloaded. I'm going to add it there, and I'm going to say recreate. And actually, I even have like one that I use here. Recreate the algorithm discussed in this paper using Python code. Where possible, only use libraries or packages from the standard library only. And then you let Claude do its thing, and then it's going to output back Python code. And while it thinks, I can also show you, I did it as well with another one that I thought it was impressive, the way it just came up with code for an entire research paper. And, I haven't tested the code, but the fact that it came back with it, it was quite impressive. So the name of the paper, if you remember, is called Applicable Lasso. And we propose a generalization of the lasso that allows the model coefficients to vary as a function of a general set of modifying variables. So he's talking about an algorithm, and here is one. And then there's many more in here. And then if you come here, it's started pliable lasso. So here's a Python implementation of the pliable lasso algorithm discussed in the paper using the standard libraries of Python, library using the standard library packages. So I don't know if it understood standard library packages as standard data science packages or a standard library of the Python standard library. But this is quite impressive. I want to test this and see where else, how far can you go? Can you take different lines of code or different projects that you don't understand very well, and then put the functions inside a language model and actually come back and get an explanation for things that could take you months to understand or weeks to understand. I think there's a lot of cool stuff that we can do with this. But with that, I'm rambling enough. So thank you very much, everyone, for your time. And thank you for making it all the way to the end. I think we still have quite a few of you here. Let's see. I had a question that I passed earlier, and it was,
Hi, Ramon. I'm really sorry to interrupt, but we
yeah,
are 12 minutes over time, so I think we're going to
okay.
right here, actually.
No, no,
Uh,
that's fine. If anybody have any questions, please send them to me in Discord. I have it's my exact same name. So thank you very much, everyone.